Hey guys, welcome to DevOps School. In this video tutorial, we are going to learn about Docker. It helps us to create, deploy and run applications by using containers. After going through this tutorial, I promise you that the concept and understanding of the Docker will be absolutely clear to you.
But before that, let me ask you a few things. Are you dreaming of a career with higher pay and more responsibilities? Or are you ready to take your skills to the next level this year? Then start investing in DevOps School certification level courses which will help you to emerge skills for a wide range of entry-level roles and as well as higher potential future positions. But with thousands of courses online and in classroom worldwide, finding the right one for your career goals can be difficult. You can consider our courses like Agile Developer, Agile QA, DevOps Certified Professionals, Site Reliability Engineering, DevSecOps, and Masters in DevOps Engineering, where you will have access to well-structured, easy-to-follow course content that has been developed and will be delivered by industry professionals. You can join on our training programs globally through online platforms, and if you are looking for classroom workshops, then we have regular sessions available in Bangalore, Hyderabad, Chennai, Delhi NCR, Mumbai and in Pune. Simply compare our many courses, find the one that suits your style and schedule best and start today.
So now what we are going to talk about, how to use container. How to use container. That is one of the main topics. So typically don't take this container as like a very special guy. Like when you run application in a physical machine or virtual machine, okay, then how do you access that? How do you use that virtual machine? So basically either you go inside this, how to go inside a container or physical machine or virtual machine, that's the one thing, correct? How to go inside a container, that's the one question. Now second thing, how can I access from outside? Can access from outside. When I say access from outside, that means it's a web application, so which you want to access through HTTP or maybe TCP, something like that. So here HTTP and all kind of things. Okay, so how to go inside a container? So before this, me talking about how to go inside a container, you need to understand the rule of PID1. Yes, rule of PID1. Let me show you the PID1 in the host machine. So here, look at my screen here. This should going up. So here, look at this PID1. Rule of the PID1 is very simple. What is a PID1, by the way? See here. PID1. What is this? System D. It gives system daemon with some parameters. Okay, daemon. It's a daemon. See, D. It's a daemon. Okay. So understand that. What is a PID1? So the rule of PID1 you need to understand very well. And if you do not understand, it's very difficult to work with container. Okay. Just. So it's very difficult to work with container. Now, when I say rule of PID1, understand this way. There is a physical machine, okay, and there is a virtual machine, and there is a container. So these are the things which we have: physical machine, virtual machine, container. So now physical machine is running. Understand that very simple rule is running as long as PID1 is running. Simple rule. Physical machine is running as long as PID1 is running. So what happens when you shut down the system? This PID1 get killed. So if this system D is running, PID1 is running. System is running. Okay. Same rule applies here also in the virtual machines. Virtual machine is running as long as PID1 is running. Okay, PID1 is running. So container is also running as long as PID1 is running. So this is the rule, you have to also remember this. So is that understood? Is that okay? Easy to understand this? Everyone?
Yeah.
So guys, in a short way, if I tell you, if PID1 is not running, system gets shut down or container will get exited. You see that when we were stopping the container or killing the container, actually we were doing nothing but the PID1 we were getting not running, simply. Now here in the physical machine, PID1 is system D, daemon, system D. In the virtual machine also PID1 is system D, but here little bit different. In the container you have a PID1 can be anything, and that's the reason you see here, Docker ps here. This is the built-in. You see here Docker exec this container and ps-ef. See here, what is the PID1 here? Built-in with certain parameters. So here it can be anything. Here it can be built-in, bin bash, Perl, Python, Java, this, that, whatever it is. It can be anything. So guys, will you remember this rule of PID1?
Yeah.
Okay. So now with that, if you have got this understanding, okay, let me prove this. Okay, let me prove this. So see what I'm doing here. Right now, Docker ps. Here you have a PID1 built-in. So can I go to okay, I have to discuss about this one also, right? Okay, let's, before proving this one, let me complete this. How to use container. So how to go inside the container. So basically guys, here you have a two method to go inside the container. One is exec method, another one exec command, one is another attach command. Okay, so exec command and attach command. Exec, I have used it multiple times, you might have seen it. So what exactly exec command will do? Exec command will execute, command would execute an executable inside a container. Yeah, so that's the reason if you see inside a container, that's the reason you must be seeing so many commands I tried with exec. See here, exec, touch, ls, diff. See all this thing I tried with exec. So here what will happen, exec command would execute an executable inside a container. But what exactly you can do, because we are a human being, right? So if you go inside this container, so with IT option, with IT means interactive, and interact with what? We are human beings, so we will always interact with the bin bash. You need a either bash or for Linux, and for Windows we need a PowerShell. Okay, I'm not talking the console and all. Okay, so this is how you interact. So with IT and bin bash combination, you can go inside. Okay, so now first let me prove this command exec. Okay, so docker exec, what you want to execute this container? ls. See, there's a command mistake. Look at this here, docker exec. See, any command you can execute inside a container using exec. But what will happen if you want to go inside that? You can use IT and bin bash combination. So what do we do? Docker exec -it container id, and with what? Bin bash. Bin bash. And now you are, where are you right now? Look at this. Where are you?
You are in the container.
Yeah, you are in a container. Now container has the same thing. What you can do is just like operating system. It's feeling as if it's operating system. Okay, so you can do whatever you want. See, applications is running PSF, and here Jenkins is running here. So this is the exec command. Now exit. Okay, done. So exit, I'm outside of the container. So docker ps. So understand that here, this one. Now what is the attach is doing? Attach will get attached, would get attached to PID1. That is it. What is the PID1 here? Look at this here, docker exec this container and ps-here. See here, what is the PID1? Built-in. So when I docker attach, what you are, I'm doing, see here, what you are. Do you think the system got stuck? Do you think the system got stuck?
Yes.
No. You are on PID, Bintini. You are on Bintini. And Bintini don't understand. This Bintini is not a shell, so he will understand your command. Only shell can understand human being, right? Correct? So Control C. And see what I did. See here. Control C, kill the Bintini. I was on Bintini. I killed that Bintini. And you see that PID1 got killed. See here, you see Bintini was a PID1. And you see the container is gone. Container is gone and got exited. See, 17 seconds ago. Got it? Got it?
Okay.
So now let's play something similar with some other images also. So I'm using one of the base images, which is a Docker run -d Ubuntu. See here, Ubuntu image I'm using. Ubuntu image is not there, so it will download. Run will download also, you know that property. And you see here, Docker ps. See, in a Docker run -d, if I do, think about it, Docker run -d, if I do and Jenkins, now this, sorry, spelling mistake. See here, Jenkins, then Docker ps, see Jenkins is running. But where is the Docker? Where is the Ubuntu container? When I remember, I run it here, you see, run -d, same command. So why, how come? So let me see that Docker ps -a. See here, and you see it got exited. Now the question is, why this got exited? Exit means I told you, right? Just a second, let me close the door.
So Ubuntu does not contain any running program, so it got exited from while you ran that command.
The question is, how come that Ubuntu container got exited, and how come the same command, if I'm running with the Jenkins image, is not getting exited? How come? Any idea? Any idea? Guys, any idea?
Can you repeat the question again, please?
I said simple, same command you see here in front of you. I run Jenkins, it run the containers, but when I run Ubuntu, which is, see here, Ubuntu, it exited the container. How come? How come? Any idea?
Ubuntu is just an operating system image, whereas Jenkins is a process that is running within an operating system.
No. Understand that Ubuntu is not an operating system. Ubuntu is here in the world of container is just a root file system application. Ubuntu is one application which contains root file system. It has no kernel. So it cannot be operating system. I've been repeating since morning the same thing again and again. So please understand this. So Ubuntu has only root file system, but it is getting exited. Why?
Because there is no ongoing process inside this container, right?
No, it has run on process. It exited. That means it's run. At least it has run one time. Guys, I told you the answer. I think you forgot. Please read one more time. Container is running as long as PID1 is running. Here what has happened in the Jenkins, when you run, simple concept, when you run Jenkins, PID is not exiting because of this. PID1 is not exiting. So PID1 is not exiting. That means Jenkins container were running. But here in Ubuntu, PID1 getting exited after. See what happens when you run the containers, it run this bin bash and then exit. So if the bin bash, which is a PID1, get exit, container will get exit. Simple calculation. So now the question is, how can we hold this? How can we hold this? So
You
you can
hold
hold
this by running
daemon mode. Daemon mode. So you should make sure that the whatever that, because I said one more thing here PID can be anything.
Yeah.
But if you have to find out the way how to hold the process, it should not get exit after the completion. So one of the tactics which we do in Linux, we use ampersand. Do you know that? Sometimes we use the daemon mode also. So yeah.
Yeah.
So now the question is, how do we hold this? If you hold this process, it will not exit. So what I'm going to do is, I am going to hold this time. So what I'm going to do, docker run -d Ubuntu, okay, and Ubuntu, and here I am saying, okay, here it will create an exit, but this time I don't want to. I am saying, boss, don't exit. I am going to interact with you. So don't exit. I'm going to interact with you. So here I will go docker run -it interaction with what? Bin bash. Of course, bin bash was set, so I don't have to set it up. Where are you right now? Where are you right now?
Yeah, in the Ubuntu right now.
You are inside a container, and if you see the process table, you see here, who are you? You are a bin bash. See here, this is the temporary one. Who are you? You are a bin bash. And if I see bin bash, how can you kill? Exit. If you do, bin bash get killed. Bin bash get killed, container got exited also. So PID1 got killed. So now what to do in this? So again rerun. Here I got inside a container. You see here, who are you? Bin bash. This time I will say not exit to come out of it. I am not saying exit, because exit will exit the bin bash, and bin bash exit, PID1 get exit, PID1 get exit, container will get exit. I don't want. So what we do? The question should be asked here is, how can I exit a container safely using, when you are on a bin bash, when you are on bin bash, the answer is control P Q. Okay, safely spelling mistake, please avoid it. Safety. I think it was correct. Okay, so how can you do that? So I'm not exiting, control PQ, sorry, control PQ. I got exits, and you see the container is still running. See, bin bash is thinking someone will come, and I am not coming. I have got exit out there. Container is running. So the concept should be granted. Please remember this. PID1 is running, container is running, PID1 is not running, container is not running. How to run the PID1? Who decide? Image developer. Image developer will decide. Okay, so now this is the behavior of container. So here these are the commands I run in order to prove it. And all this thing you have here. Okay guys, now here I taught you how to go inside a container. So here when you attach, make sure that if you want to attach here, so make sure that you attach to somewhere when the PID1 is bin bash. See here, clear the screen. See here, right now when you see there's a three container, Jenkins Bintini, Ubuntu, bin bash. So when you attach to the Ubuntu container, so then you will get on the bin bash. You can interact, you can do whatever you want, but control PQ. When you attach to the Bintini, then you know where to go, where you'll go. Okay, so for example, okay, docker ps, when you attach to this container, you'll go to the Bintini, and Bintini don't understand your commands. Bintini only understands something, some shell scripting and all. Make sense? It can, here instead of Bintini, it can be Java, Perl, Python, Scala, MySQL, MSQL, whatever, you can keep it here, but it should be running. That's the concept. That's our concept. Make sense, guys?
Yep.
Okay, so now we have covered many things. We have covered many things. Important things which I want you to try is I am going to give you the system. Okay, I am going to give you the system. A system where you will have a Docker installed, and you can create and you can play with the life cycle of container. This is the life cycle of container, and then you will go inside a container, this one, okay, and stuff like that. So by the way, Jenkins is one more thing which I missed out as of now. How can I access from outside? So look at this guys here. Look at this. Docker PS. Jenkins is a web-based applications. So can I get the IP address? Docker inspect. Okay, container ID and grep and -i IP. Okay, see this is the IP address. Jenkins run on 8080 port. You know that. So HTTP curl. You have to do the curl. HTTP dap and 8080. See here, this is the Jenkins login page. You want to change the port? I don't know, it's a 2, I think. 2. See, so both the Jenkins is accessible 2 and 3. But the question is not accessible here. I am not enjoying that HTTP over the command line curl. I have to enjoy over the browser. But the problem here, that's a VM server edition, so I cannot have a browser here. How can you do that? So I'll talk about that. Let's play with one more image. So Nginx. Nginx is one of the server. So here Docker run -d nginx. One more image I'm playing with. Nginx is a web server. Okay.
Yeah, Ubuntu will not get a IP address, right?
Ubuntu will get IP address, but there's no web application running. No. So what you will do with that?
No, but let's say if I do a SSH to Ubuntu, I can do that, right?
So you have to install SSH server inside that. That is not there. Remember?
Okay. Yeah.
SSH server. You need to have a client. There need to have a server.
Correct. Got it.
Okay. So here Docker PSC. I got one more container, Nginx. Now Nginx has a Nginx software. So can I inspect this IP address? Inspect container. And then grep -i IP. See here, this is the IP. Okay, so can I see this curl HTTP data? See here, this is the website. Now you want to see the attach, use of attach. So let me do one thing. Let me first show you the commands. So this is, you can try in the HTTP. Okay. Okay, now let me show you here. One more thing. What I was trying is, yeah. So I'll create one more session. Okay, CentOS. Okay, sudo -s. Now you see here, I will attach to the Nginx container. So Docker. See, when I attach to Nginx container, where would I go? I'll go to this one. Let me see that what exactly that is. So Docker exec container ID ps-ef. So what is that? Wait. Okay, so unfortunately the ps is not installed in this container. That's the reason it says that this command is not found inside the container. So what do we do? You can inspect also. So inspect, I can find out the command line. Clear the screen. Docker inspect container ID, and here entry point here. So Docker is running this one. Okay, this one entry point. Okay, so they are running this one. So now let me attach to this. So Docker attach container ID. Docker ps Docker attach and container ID. So here, right now it's nothing, because where are you? You are on an entry point. Now if I access hit from that outside, let me get the IP address of container, which is IP address is 5. Okay, So see here, look at this. Curl and nginx run on 80 port, right? So curl http, see here, one request. You can see the live request, live log and stuff like that. Got it? So this way. Understood this? So attach will give you the PID one, whatever the process running at, it will show you that. Make sense? Understood, guys? Hello?
Yep.
Okay. So now this is the one. But one more thing which is there, and that question is not answered so far. And the question is, how can I access from outside? So we have to understand few more things here, guys. Understand this here. Okay. So see here, this is the VM. And this is the IP address. This is me. I can access this IP address? Yes. But the container, the IP address, whatever they get it from the Docker bridge. Okay, Docker bridge. The container has IP address, but the container 1, container 2, the IP address, whatever they get it, the IP address this container, its scope only is accessible to local. For example, in a simple way, if I put it up, let's say you have a one house network, Wi-Fi, and Wi-Fi will give you, router will give you the IP address to your laptop. So do you think that IP address is accessible from outside? No. Why? Because the scope of that network is local only. So how can I access from outside? So then there is a concept called proxy. The same concept even AWS is using for the public IP and private IP. So what they do, you will hit to the node IP address at certain port, which is like say 81. Okay, and this port ETH0 will receive that request, and ETH0 and Docker bridge, which is on the same line, this will transfer the ARP to this one, and this guy knows that where to transfer at the which port. So this will direct to here. This is called port forwarding, port proxy. Okay, so here what we are doing right now is we will create a new container, run -t Jenkins. This will create a new container, but also we are doing mapping -p 8080 external port, 8080 internal port. When I say 8080 internal port means container port. This is node port. So now if you want the second one, you have to change this one, and container port will never change. Host port will change, because you cannot use same port again, external port, this one. Why? Because you have only one network at the host machine. So right now I'm creating two more containers. Look at this, my screen here. One container, sorry, what is that? Oh, back to me. One container, two container, Docker PS. See, there is a two container running. See that these two containers, one is exposed from 8081 node port to the container port, another one 8080. Now these two containers I cannot access from outside, but these containers I can access. Now what is the node port, host port? So for that, let me access the IP address of node, which is this one, and one is 8080. And another one is 8081. 8081 or something else, I forgot. 8081, yeah. See here. So this is the way you can access from outside. See, here also it will come in few seconds. So guys, did you understand that? How to consume container? That was a question. So here I taught you first of all rule of the PID1, then how to use a container. So either you go inside or access from outside through IP address, or if you want to access through a browser, this is the one. Did you understand this?
Yep.
So guys, this is the world of containers. Faster, better, cheaper, and portable any places. So now I'll give you lab time. Okay, I'll give you lab time of 1 hour, and then after that I'll teach you these topics. So before that, let me recount this stuff. All the commands you have in the same notes. I explained it to you also. Hopefully you remember. What you need to do, you need to run life cycle of the container. You need to prove it, what is container yourself. You need to use the container using exec, attach, and you need to access from outside. Everything you have to do in one.
Can you label your container? Like, because we all will be possibly in a real world, we'll be creating our own containers for let's say Jenkins. So how would I know that which one is my Jenkins container? Can we label them?
Yes, I'm coming back. Yeah. Now the question is, because if you work in the same machine, lots of containers will be there here, and it's very difficult to know which container belong to which one. That's a problem. So how do we solve it? Very simple, guys. I don't know. My name is Rajesh. So I remember only this one. That means any command you run, create, okay, with that. This command is for the run and create. Create and run. So any command, any container you create, you have to give the name. For example, I'll give the name. Something like hyphen name. What is this? Rajesh1. Okay. So see, I'm creating one container with my name, and I'll get to know who has created a container and who has not created a container. So here you see, I'm running this command, docker run -d Rajesh1, and what is that? Okay, that port is being used, right? So you have to change the port 82. So see here, now name is being used. So you have to change the name also. Rajesh2 port this way. Okay. So you always unique name. Okay. See here, and look at this. I'll get to know Rajesh has created one container, and this is owned by Rajesh. Did you understand that now? So please use this method to differentiate your containers with your container. This hyphen name, you can pass it to containers with the commands with the create and run. So I think we are done with it. Now I am giving you the boxes.
If you liked our Docker session so far, please enroll our general membership for $399 plan to get access of all the parts.
Along with that, you can access our other tutorials such as Docker, Ansible, Jenkins, Terraform, Splunk, AWS, Azure, and various other DevOps related premium tutorials with our channel membership. If you would have any issues with our channel membership, you can drop an email to us at contact@devopsschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. To get our channel membership, click onto the join button, select the $399 plan and grow your skills immensely.
Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest.
Thanks for watching.